Hello, this is Danny.
And Mark from the Media Molecule Design team.
And we're back with another Little Big Planet tip special. This time we're going to focus on switches.
A lot of you will have seen the amazingly complex contraptions built by some members of the community. But don't let the scale and scope of these projects scare you, because with just a few insider tips on how to use switches, you'll be able to add many new kinds of gameplay to your levels.
Examples we use all the time in the developer levels made here at Media Molecule include one-shot mechanisms, toggle mechanisms, counting mechanisms, delay mechanisms, multitask switch mechanisms, and simple logic test mechanisms. The basic ingredients for a switch-based piece of gameplay are an obstacle, a puzzle to solve, and a clue to help the player.
First off, a really basic concept, which we covered briefly in the previous tips video. One-shot switches.
In this example, we see the limitations of connecting a button directly up to a piston-controlled door. The door only moves when we stand on the switch, making it impossible to get past.
To fix this, we need to manufacture a one-shot switch mechanism. This works by connecting the button up to a piece of dissolved material. When the material dissolves, it deletes the magnetic key which is attached to it, and this in turn triggers its twin magnetic switch.
To make this work, the magnetic switch must be inverted, so that it detects that the magnetic key has disappeared from within its trigger radius.
This switch is now permanently turned on, and the piston which it's controlling will keep the door open forever.
A two-way switch will let you toggle between two different states, but toggling using two different switches is a more complex problem. But it's also a rather common gameplay device.
To do this, we set up a piggy-in-the-middle style mechanism, with two pistons, each controlled by separate buttons, pushing a magnetic key back and forth past a magnetic switch.
One piston pushes the key near the magnetic switch, turning it on. The other piston pushes the key away from the magnetic switch, turning it off. Here we're going to set up the condition that the button must be pressed several times before the door will open. This is done by hooking up the button to a fast-moving piston.
Each block of dissolved material in the queue is set to delete itself when the magnetic switch is activated by its paired magnetic key sitting on the end of the piston.
This mechanism is easily expandable by adding as many blocks as you require. The final block is the one which opens the door, using a pair of different coloured magnetic key switches.
Delays are essential for fine-tuning the timing of events in your level.
A delay is easily achieved by putting a pair of magnetic key switches on a piston. The speed of the piston's movement is analogous to the length of the delay.
The trick here is to use a one-shot switch mechanism to make sure the piston is only activated once.
An individual switch can only be set to one type of behaviour, such as speed scale, on-off, or direction.
But if you want to control two or more different behaviours from just one switch, then you'll need to construct a multitask switch mechanism.
To do this, we use the trusty magnetic key switch again. Using just one magnetic key on a piece of dissolved material, we can control as many magnetic switches as we like, and each of those switches can have a different behaviour.
In this example, we control the door with the direction behaviour and trigger the camera zone with on-off.
An AND switch is a simple logic mechanism which only activates when all of its inputs have been switched on.
There are several ways to implement this, but one of the most reliable is to use a magnetic key switch with two or more magnetic keys.
In this example, each switch controls a piston, and both magnetic keys need to be moved out of range of the inverted magnetic switch before it becomes activated.
An OR switch is another kind of simple logic mechanism which activates when any one of its inputs have been switched on.
Here we're using a magnetic key attached to a series of 2 pistons. Each button controls its own piston, and if just one piston expands, then the magnetic key will be moved out of range of the magnetic switch, activating the door mechanism.
There are a plethora of tutorials available online which helpful members of the Little Big Planet community have put together to explain these concepts and more in great detail.
Check out some of these levels to expand your knowledge of switches.
That's all from us.
I hope these tutorials have taught you something new and have inspired you to get to grips with using switches in your own levels.
Until next time, bye-bye.
Bye!